Wow. Hey there, Mary and I dropped the attic temperature in our attic by 38 degrees with the addition of this radiant barrier. And what we're going to talk about today is the physics of why it works so well and why air ventilation is so important. Then we're going to talk about how pairing it with powered attic fans can cool your attic even more. See, here's the problem. Imagine this attic without the radiant barrier. As you can see, we've got 2x4 truss work in here, and those trusses run down the length of the roof. Air comes in, air gets exhausted, but the sun is always beating down on the roof structure. So during the day, this heats up and heats up, and it'll get over 150 degrees in here without any proper venting. And what we used to have is just static venting. We would have cool air coming in from the soffits, and it would come up and slowly exhaust out the side vents we have in the roof. Now, your house might have a ridge vent that runs right across the top of the ridge. Ours doesn't. Ours has 4 roof vents here up on the side, located about 5 feet down from the top of the roof, from the roof peak. So what we've done here is we did not want that air in our attic. It was heating up our AC plenum. It was heating up all the structure, the catwalk Mary and I are standing on right now, and it would just make for a very hot time. The problem is at night, that heat would take forever to get out of the attic. So we decided to come up with a solution. We did the research and we found radiant barrier. Now with radiant barrier, you don't just slap it up on the underside of your roof deck, because you can actually cook your shingles doing that. You need to have an airspace between your radiant barrier and the roof deck in order for the reflective properties to work properly, in order for airflow to be able to be carried through. So in our case, because we have 2x4 truss work, we were able to put this radiant barrier up perpendicular to the trusses, and we've got a space. You can see my hand here. We've got a space of 3.5 inches, and that's just plenty of space. What we've done essentially is to create thermal highways. If Mary pans the camera down, you can see it's kind of hard to see in here, but there is a space at the bottom of the radiant barrier, and then the channels run right up through, and they go right up to the top of the roof, and we've left the space up there as well, and we'll show that in the B-roll. So our thermal highways start out with cool air that enters through those spaces. It runs up through and gets heated, and it's going to get heated even more because of the reflective properties of the radiant barrier. It's going to run up to the top, and with our fans, it gets pulled and sucked right out of the roof here. Hey everybody, if you like this video, please hit the subscribe button, hit the like button, and share it with your friends. We're building a community of like-minded people who value sound home engineering solutions like we employ here in our home. We'd love to have you be part of the family. Thanks. So what we've got are, and we'll show this in the B-roll, these are AC Infinity T10 fans. They're omnidirectional, so you can shoot them up, you can have them at an angle, they can shoot down. You use them for venting in greenhouses, etc. They come with louvers. We just took the louvers off. We built the box for the 10-inch fan, and what this does is it forces the air through the roof vents. We have 4 fans because we have 4 roof vents in the house. Now, one thing to remember is you can't just put 1 or 2 fans in, because they'll push air out of the attic, and if you have other vents, air follows the path of least resistance. Air is going to be pulled right through those vents, and you're not going to do anything to cool off your attic. So if you have roof vents in a configuration like ours, it's all or nothing. If you've got 4 vents, you need 4 fans. So once they're in here, we put the plenum box up. They can run up to 600 cubic feet per minute. So our 4 fans can pull 2,400 cubic feet of heated air out of our attic per minute, which is awesome. It's very important to note that if you add fans into your house, you're altering the dynamics of the airflow in your attic. Your attic is designed for that net-free air to just kind of percolate up through the soffit vents and just to come up through. And what we're doing is we're sucking air in from the outside now and pushing it through the vents. But we have an imbalance. So whenever you put fans in, you've got to calculate the extra venting, the makeup air that you're going to need to put in your house so that you can get air to replace the rush of air that you have from these fans. And for us, it worked out really well. We were able to put 4 additional soffit vents over our entry door. We were able to put a couple additional grills out on our lanai. We pull a little bit from the garage, and all that makeup air helps complement and just makes this a very comfortable place. And that's the important thing. You need that air ventilation. So here we are, the AC Infinity vent fan. AC Infinity is an excellent company. We've been doing business with them for over 10 years. They make fantastic products, and they have many different products to choose from. So let's break down the fan. It all starts with this here. We've got this black wire, and I want to be careful I don't fall down in the attic onto the ceiling here. This is our thermocouple right here. This measures the temperature, and that's where the fans get their intelligence from. We have it here at our level where we work and do our stuff in the attic. We don't have the temperature probe up in the peak of the attic because we don't care about the peak roof temperature. We don't live up there. We don't store stuff up there. We don't put our heads up there unless we have to. We do our work at this level. So this is the temperature that we measure. Next to it is a thermometer, and that's coupled to a wireless display downstairs. And that is separate. That's just something that we use, and we have two means of measuring temperature up here. All right, now we're going to talk about the controller, which is the actual brains of the operation, which controls the fans up here. Again, the fans are variable speed. AC Infinity provides this particular controller box. I'm going to unhook it here, and it's very simple. If you look on the back, it's got a power cord that goes in, and then each of the four fans connect to it. You can use multiple controllers for your projects. In our case, we only have 4 fans, so we only need 1 controller. What you have here is you've got a display up at the top for each fan. So each port is labeled. You can program each port. In our case, we program them all the same. It's hard to see on the display, but it says that the temperature where this thing starts to run is 85 degrees. It's currently 82 degrees in our attic right now. So once the temperature reaches 85, the fans start running on power level 1. And we've got them stepped up so that as the temperature rises in here, by the time it gets to 94 degrees, we've got the fans running at 10. And at 10, they're pushing 600 cubic feet a minute out of the attic. And then they run until the temperature drops to 85 degrees, and that's it. So that's how simple this system works. I'm up in the attic now, and let's talk about the controller. The phone comes with an app, and that's how you set up your controller. There's the screen, and you click on the screen, there you go. So you're able to adjust things. I won't get into the adjustments now, except to say that it's very simple to monitor and control this thing. So that's it. So let's talk about cost. If you saw our other videos on radiant heat, we'll have links in the descriptions below if you haven't seen them before, and we highly recommend you watch them because they are popular and you learn a lot. We spent $1,200 installing the radiant barrier in our attic, and it was about $1 a square foot because we bought 1,200 square feet and we installed about 1,150 square feet. So $1,200 there. These fans run about $200 a piece with tax and shipping. So that was $800 to put these in here. So we put $2,000 into this project. For cost savings, it's not like you're going to see cost savings just like that. When you're taking air and cooling it in a building or in your attic, like in our case, the cost savings are small, they're incremental, and they just add up over time. Our payback period, we figure, is going to be 5 to 7 years, maybe 8 years, maybe less. And what we're doing is we're saving on the cooling portion of the electric bill. Now, one of the big criticisms that we get, a lot of people get when they talk about how their radiant barrier products work, people will ask, hey, what's the cost savings? You're not sharing the cost savings, so how do we know this really works? Well, these cost savings don't actually just jump out and go into your wallet. It's a little bit of money at a time. We figure we're going to save 10 to 15 bucks a month in the hottest months of the year here in Southwest Florida using these products and pairing them together. Now, you don't see it. It's just a portion of the cooling bill. And unless you use metering, smart metering or something, and you actually track how much amperage goes through your air conditioning system, you're not going to know what you save. But you may see a slight reduction on your electric bill, and that's how the savings happens here. It's not something that's super tangible. It happens over time. But this stuff is cumulative. It keeps pushing air out. It keeps blocking the sun. You get the benefits over time, and it's absolutely wonderful. Now, the nice thing is that these two systems work together in a very synergistic way. You're blocking radiant heat from the sun, but you're getting convective heat that's building up in the layers of these thermal highways. That's what the fans are here for. They're here to take any of that convective heat, and they're taking it and moving it out of the house, and that's how these systems work together. Okay, the foundation of any roof ventilation system is the soffits up here, and Mary's going to do a close-up of the soffits over on the side. These are slotted panels. These are slotted panels up on the roof, on the base of the roof here, and air enters those slots. that air then moves up because it starts out cooler, then it migrates up toward the top of the roof. As it gets up toward the top of the roof, it escapes from roof vents. The idea is that this air goes in freely, collects heat, and exhausts out the roof. And you'll see the roof vent in the B-roll. Now, when you have a home like this, if you're going to put power fans in, you have to increase your flow, because when a builder builds a house, they take these soffit panels and they have a measurement of how many square feet of soffit panels you need in order to provide a certain amount of airflow into the house. That airflow has to match what can be exhausted out of the house in the roof vents. And if there's an imbalance in those numbers, the worst case would be that you don't get enough air coming in the attic, so your vents starve for air. And that can happen when you use powered fans. So what you have to do, and you'll see that in the B-roll, is you have to increase air going into your attic to make up for the amount of air that you're pulling out. Otherwise, you might pull your conditioned air out of your living space. Hey, if you're getting value out of this video, please hit that subscribe button and please hit that like button and share it with your friends. We're working to build a community of like-minded people who value this kinds of real-world engineering projects in their home, solving real-world problems and making real-world benefits happen in their own homes. So we'd appreciate you joining our family. So thank you again. So that's it. This is the radiant barrier system that we've installed in our attic. These are the AC Infinity fan sets that we had put in here. Paired together, they make an incredible system for managing airflow and managing temperature up in our attic. It makes the attic much more comfortable. Our garage is much more comfortable. Our AC doesn't run as much in the home now. This project has really worked out well. Thank you for watching. We look forward to seeing you on other videos. Thank you.